The challenge is to find one that's unpopular.
Yeah, I'm not so worried about that. I'm more worried that like I'm gonna say something that nobody can even answer. Like I'm inclined to say something about like Go's garbage collector and just garbage collection design in general, and now I'm just kind of like, oh, is anyone going to be able to relate to this?
We are live, by the way.
Definitely do it though. That could be a great one. Yeah.
All right.
We are live. Did you say?
We're live on YouTube. I'm gonna try to see if I can get the thing to push us live on just the audio only stream on Changelog's website too.
Yep. Okay.
We have to do a clap at some point.
Okay.
I have like way too many things to do these days.
Yeah, there's lots to do, isn't there?
I have to like start 2 different live streams, my own recording. I've got to do this backup recording.
Yeah. Okay, I'm just testing my recording. Yeah, I think I'll go. I won't do the clap. We can do the clap now if you want, John, if you're ready.
Yep.
So, Michael, all we do is we do 3, 2, 1, and then clap after the 1.
So clap on 4.
And we only really get one shot. It's used for synchronization. It's useless if we get it wrong. If we do like 5, then that's no good. Okay, so we'll just do it now. 3, 2, 1.
I love how you say we're going to do 1, 2, 3 clap, and then you went backwards.
Oh, yeah. I mean, to be honest, it worked.
It worked. I was just laughing because I'm like, you literally just explained it the opposite way.
Yeah. Well, we used to do 0 bound. We used to do like 3, 2, or like 2, 1, 0 clap. And it was just too silly. Yeah. It was just clever. It's cleverness where simple was better.
Is that like your captcha test for before we start the show? You're like, if anybody gets this right, they're clearly a robot and we're kicking them out.
Yeah, exactly. We just make them click that I'm not a robot box, which I feel like any robot, even the most rudimentary robot, would be able to click that button. Do you know what I mean?
AI hasn't figured that out yet.
Yeah, I mean, what? It can drive cars. How? If it can't be clicking that button, I don't want it driving anything. Do you know what I mean?
I want to believe that button does something else to check, but I don't know what it could possibly be.
Yeah. Have you ever had it where you click it and it says
like mouse patterns and stuff?
Have you ever done it where you click it and it says, "Oh, sorry, you failed. You are a robot." No. You told me before you are a robot. Now you've proved you're not by showing me what bicycles are.
It doesn't like Stripe.js have like fraud detection stuff built in? I'm assuming they're doing something similar on both ends. Like, is the person just going straight to the input box and clicking versus? I mean, I know you're joking, Matt, but
yeah, they check. I know that they look at they track you with cookies, so they look at that, and often from that you can tell it's a real human or not. And if they can't do that, then they fall back to some of the kind of captures and stuff. But I don't know. I mean, all the best robots I know could easily get past that. Terminator.
Robots all have cookies and they go to all of these different websites.
Does the Terminator have cookies in his head, do you reckon? Like he must have, probably, right? It's going to be built on some web stack.
It's all JavaScript under there.
It basically will be by then. By that point in the future. That's what the war's all about, probably.
Have you seen the talk? It's called, I don't remember what it is, but it's like JavaScript dies and simultaneously takes over the world because it now becomes like the OS that we run on top of. It's just a browser and JavaScript, and all of our modern infrastructure is built on top of that.
What is that? Fiction or non-fiction?
I think the talk was structured in such a way that they were like, we're already in this future. This is how things just work. It was like related to Asm.js, I think, the project. It's like just compile all your code to JavaScript and run it in this beautiful sandbox. Nothing can go wrong.
Yeah, it's quite compelling though. That's the trouble with it.
I'm like genuinely not sure how the Terminator would work, given how much like Internet of Things, like all the devices that go offline when AWS goes down.
Yeah.
You go back in time where there is no AWS. Yeah. Like this isn't going to work.
Yeah. Do you think he runs on AWS?
I mean, he's got to be using some sort of cloud stuff.
You'd think it'd be abstract cloud if he needed that, but
it's anything like our current timeline where we just make everything in the cloud.
Yeah, maybe Terminator just got loads of Raspberry Pis running a Kubernetes cluster in his tummy. You know what I mean? Probably. Could be. Robocop's got a gun in his leg. can just get that whenever he needs it.
I haven't seen those movies in so long.
Mm.
Remember, like I was young and my parents would be like, "You aren't allowed to watch this. It's an R-rated movie." But like it was still at the house somehow. It was like the movie they pulled out to test the surround sound system.
Really? What was it? Horror?
I think so. Because like all the shooting, or I don't know. It was just. I remember a new surround sound system. I was like really young at the time, and like that was the movie I think they got out to test it, and I wasn't allowed to watch it.
Yeah. Fair enough. Okay, we should maybe start the. Remember that podcast we're doing?
Maybe. What? Wait, sorry, what?
Yeah, we should do that.
Okay. I guess I'm ready for that.
Everyone's recording locally. We've done our clap. Yeah. We're going to play intro music, John, or we're just going to go
I'm not
straight
doing intro music. I don't even know where it is right now.
Okay.
Sorry.
No, that's fine.
It's easier if I'm not actually talking on the show. When I'm talking, it's like there's just a bunch of other stuff.
Okay. Well, I'll just do an intro and then we can jump into the conversation. How about that? Okay. Hello and welcome to Go Time. I'm Matt Ryer. Today we're talking about what happens when Go programs end. What happens when the Func main returns? What happens to Go routines that might already still be running? Or remember those deferred statements? What's happening with them? Are they going to go? What about open files? Do they get closed for me or do I have to do that? What about those HTTP response bodies? Supposed to be closing them. I hope everyone's been remembering to close response bodies. But what happens to those when you exit? Well, there's loads of questions, and we're going to find out the answer to all of them on this deep dive forensic analysis breakdown edition. Super cool, where we look at what happens when Go programs end. So yeah, a very dramatic intro for what could be a very mundane subject, but I don't think it's going to be. Joining me today to discuss this, it's regular John Calhoun. Hello, John.
Hey, Matt.
You told me earlier you've never had a Go program end. So this is uncharted.
Say that.
No, what did you say?
Most of my programs aren't designed to end. So when they end, what happens is I'm trying to make sure my server gets it back up.
Right. So interesting. So, okay. Well, I'm sure we'll talk more about that. We're also joined by a member of the Go team who's been working on the runtime for the last 2.3 years, he told me. Welcome to the show, Michael Knyszek. Hello.
Hello.
Welcome.
Thank you. Excited to be here.
Okay, good. Is that real, or is he just being polite, showbiz polite?
I am nervous, but also excited.
Okay, same. They're similar, aren't they? They're similar things. Okay, well, let's start for maybe right at the beginning then, for someone new to Go. What happens? I mean, ultimately, a program at the end will stop running. So what happens there? What's going on?
Well, I guess what basically the Go itself is just gonna sort of. This is gonna come out the wrong way. Hopefully, we'll dive deeper and explain why and what. But Go kind of just leaves a mess behind and calls directly into the operating system, just like we're done with everything, and everything dies and gets cleaned up. And the operating system goes and cleans everything up. And if that running Go program had a parent process, on Linux all processes have parents, so then it returns it gives that processor that parent a return code. So on Linux, it's I believe usually some value between 0 and 255. For compatibility reasons, Go is os. Well, I won't get into os.exit yet, but basically Go by default returns 0, which means all good. Returning anything non-zero effectively means something went wrong. Some programs like to use a different number for different meanings of something went wrong, but generally that's the pattern. Just everything went fine and something went wrong.
Okay, great. And are they like HTTP status codes, those exit codes? Are there any standards, or is it just that 0 means it was success, everything else is then defined by the program?
I think that's the only thing you can actually rely on. If you're dealing with a specific program, like you're writing like a wrapper script for it, and you want to have like maybe another error message come out or log that somewhere, then it can be useful. I feel like I know a few programs that like define in like a big table like what all the different values mean, but I think in general the only thing you can rely on is 0 and non-zero.
Right. So in Go, a main function, when that returns, there's no return argument, so it just returns by falling out the back of the block. That will just by default return as 0 then, would it?
That's correct, yeah.
And then if you do want to return something non-zero, that's when we need to look at OS exit.
Yes, precisely.
Okay, well, we'll get into that later. But you mentioned that everything gets cleaned up by the operating system and Go kind of leaves a mess. What things get cleaned up specifically there?
So basically, Go asks the operating system for a bunch of memory. So the most obvious thing is all that memory gets collected. So basically, all of the memory-related resources that the OS has given the application get reclaimed. Other things include if there are any open file handles, and so this extends quite broadly. But in the simple case, you just have like a file on your local hard disk or something like what you usually think of as a file. Basically, the OS will close that file handle for you. It keeps track of all of them, and once your program exits, it goes over all of them and just says, okay, this process is no longer using this file.
So that's cool then. So the memory, reclaiming the memory is nice. So then if we've got some program that has a massive map of data, before we return, we don't have to go through and delete all that data, do we? We don't have to go and do that sort of cleaning up, releasing memory. That will just happen automatically.
Precisely.
Right. Yeah. And then the files one's an interesting one because you can, if you open a file in Go, and normally we defer the close of that file, or you might have some other mechanism for closing that. If you don't close that file and the program exits, does that leak a file handle, or does the operating system clean that up?
No, the operating system cleans that up. So files on most systems are like pretty. The concept of a file goes pretty deep into the OS. So it actually does keep track of these things and does say like, okay, this process exited, and it usually keeps like a reference count for these files. If I recall, I'm a little bit rusty on this part, but and it goes and decrements that reference count.
Right.
But basically, it does the equivalent of closing any open files you have.
Mm-hmm. Right, of course. So if you've got that code in a loop or something, then it's important to remember to close files as you go. You can't rely on that program ending. Yeah, very cool. John, how do you normally exit and deal with cancellation and things in your programs? If you write a command line tool, how would you do it?
I mean, the most common way you see is, wrap or using context and sort of handling it that way. But I can definitely say I'm guilty of not doing that all the time, especially when it's, if I'm writing something, just a quick tool for myself or whatever, and I don't expect it to take very long. If it's only going to grab 3 files, parse them real quick, do something and be done. Usually if I wanted to cancel it, the program would be done before it ended anyway. So it really doesn't make much of a difference.
Right.
Now, if I had something more long running, then maybe it makes more sense. I guess it kind of depends on what you're doing and whether or not stopping in the middle of something is actually really bad or not. So that's kind of like the determining factor for me is does it actually matter if it just stops?
Yeah, so that's interesting. Does it matter if this program just stops? And you can imagine programs, and I've written one recently that was processing files, and it would open another file to generate some data basically from the first file. So it would create a new file for each file that it found. And it was kind of, because it was a small hacky thing, it was relying on the existence of that file for state to see whether it had been processed or not. So in this case, if the program just ended halfway or in the middle of all that somewhere, I could end up in a state on disk that wasn't desirable and didn't reflect the reality of it. So that leads us kind of into this sort of talking about a graceful shutdown as well, where we notice that a program wants to end, or the operating system or somebody wants to end this program, but we've got some work to do before. So what are our options for doing something like that? How do we know that the program's going to end, and how can we then do some work before?
So programs can really end, broadly speaking, can end in two ways. Either something tells the program to end, or it tries to, it decides I'm done and closes itself out, right? So in the context of something external, you might see something like Control-C. So if you type Control-C in your command line, then what basically happens is Linux sends what's called a signal, which are surprisingly difficult to work with correctly outside of Go. Go actually makes this quite nice to use because it wraps the whole thing in a channel. But you send, once your program receives a signal, it needs to handle it in some way. And so with Go, you can use the OS signal package to get notified about when you get something like Control-C. Something wants to end your program, and so using the OS signal package lets you capture that and say, okay, let me do the cleanup that I need to do so that I can get my graceful shutdown. Internally, there's sort of more, if the program wants to end internally, there's sort of more of an assumption that the program as a whole would know that, and if it wants to gracefully shut down, then it has to provide its own mechanism for doing so.
Right. Yeah, that makes sense. So is that quite messy in the runtime code there? Because I imagine there's lots of edge cases that it's dealing with, and lots of different operating systems, right?
Well, signal handling is notoriously difficult because a signal handler can run just about any time on any thread, which means that a signal can land where you're right in the middle of holding several locks, and you're like, okay, is it safe to do anything? So yeah, that part of the runtime is actually quite tricky and difficult to get right. And it's also a complicated part of the OS too. Austin on the Go team found a bug in the Linux kernel related to signals in the Go 1.14 release cycle. So it's tough. Yeah.
Yeah, I mean it's quite old. It's old tech, really, isn't it? Because it's really core. So it's really deep somehow in amongst this.
Yeah. So, but the signal package does really give you a very nice wrapper around this. It's very safe, much easier to use than a regular signal handler.
So let's say I'm jumping into this and I want to figure out how to capture signals. Do I have to learn about a bunch of different signals? Like if somebody's using kill in the Linux terminal to drop a process versus Control-C versus a bunch of different ways you can try to stop a program? Or is this kind of, you pick one or two signals and can go from them? Where does somebody start if they want to get started with this?
I think the OS signal package documentation does describe the different signals pretty well. It's funny you mentioned kill, because if I recall correctly, kill is one of those signals that you just simply can't catch. That's what's kind of dangerous about kill, is that if you send kill to a process, it never gets the opportunity to clean up. It's like a force quit, right? There's no opportunity. The other two that I'm aware of are sigint, so that's interrupt, that's Control-C, and sigabort is kind of interesting because that will cause the Go runtime to actually dump a bunch of coroutine stack traces. But sigabort is another one that is sometimes useful to handle explicitly, but Control-C is the big one. I do think the OS signal package provides some pretty good documentation on this, because it's also wrapping around the fact that you have lots of different, Go supports lots of different platforms, and of course this is going to work slightly differently on Windows and stuff. So I defer to the OS signal documentation for precise semantics.
Fair enough. And since Go 116, we actually also have a notify context helper too in the signal package, which will cancel a context on a signal. So that's kind of like nice. So if you're using context for cancellation across your program, and this is essentially the pattern for anyone unfamiliar, where you pass in a context argument as the first argument through the chain of all your programs. And then whenever you've got loops within that of work, or maybe you're iterating over a set of data, you can just periodically, i.e. at the start of each loop, check to see if that context is finished. And there's either a channel that'll be closed, or you can check to see if there's an error being returned. And then you can abort that operation. So that's a nice way to do kind of graceful shutdown, or at least you'll finish what I'm currently doing, and then I'll stop. Gives you that sort of graceful shutdown. You can do that quite nicely with context, but you used to have to write that signal code yourself. And with the addition of notify context, you don't need to anymore. You can just wire it up to a context, and it will be cancelled for you when the program's interrupted. And I think it's good practice. This is something I always do. If you get a second interrupt signal, then it's worth doing a more serious exit. I mean, sometimes I think operating systems will send a kill as the second signal, but if it's just a command line and you press Control-C and something's wrong in your logic somewhere, you can easily hang because you've caught that signal. So it can be good practice to look for a second one and just do an immediate OS exit. And that way you never get caught having to go and try and force quit your own business. Yeah, so graceful, that's kind of graceful shutdown, I think, is very cool. Another way to get a kind of form of graceful shutdown, or at least of cleaning up after you, is with the defer statement. So in the func main function, when you defer things in there, they do get called before the function exits, and therefore before the program exits. But that's not true for OS exit, is it, Michael?
No. So OS exit is a hard exit. It basically does the minimal amount of cleanup necessary, which basically for the Go runtime just means if you're running with a race detector enabled, it'll do some cleanup with the race detector, and so try to signal that, like, oh, if you have a racy program, it's going to make sure its exit code is non-zero, for instance. Mm-hmm. But otherwise, yeah, it basically just does a hard exit. It doesn't bother trying to run deferred functions. It also doesn't bother trying to run finalizers if you're aware of those. Kind of a dark corner of, but worth mentioning.
Yes. Okay. So OS exit is a very immediate stop, and you're not going to have the nice things that Go would give you. So you do have to bear that in mind. Another thing that's quite interesting is what happens to the standard in and out streams and standard error. For example, does standard out receive an IO EOF at the end of it? Does it do something to close the pipe? What's actually going on there? Is that operating system dependent too?
So pipes are well, that this might be somewhat system dependent. I'm thinking more in terms of the like Linux, Unix sort of philosophy, where pipes are just files. Like to the operating system, it's like it uses the same sort of resources, file handle, right? And these like standard out, standard error, standard in, all get closed in exactly the same way as any other file. So I will note that the moment you do this sort of exit call, whether or not code runs is sort of completely up in the air, right? Some Go code may run in that few milliseconds before the process gets taken down, or the rather its thread stops, but you can't rely on that, right? So there's no EOF propagated through because it doesn't even, like, there's no code to even process that IO.EOF, if that makes sense. Like the code is not guaranteed to run at all.
So when we call os.exit, you can just assume that from that point on, it's like somebody just walked away and whatever happens, happens, but it's all tumbling down at some point.
Yes. Yeah, it's a very, very hard exit.
And that's the one that's actually the only way you can return an exit code that's non-zero, isn't it?
Right.
So that's interesting then. So you have to be careful with that. But you may well want your program to exit with a specific status code. But if you're doing that deep somewhere in your program, it's possible other things aren't happening. So you probably would only want to use OS exit right at the top in the main or very near there, wouldn't you? Based on probably the return from some other functions that you're creating as part of your application.
Yeah, that's generally a good pattern. Basically, what I see is like you have main, and if you just return cleanly from main, then that's your exit 0. Because actually, interestingly enough, if you look under the hood, when you return from main, all it does is do a very tiny bit of cleanup, which is that race detector stuff, and then it calls the same exit system call. It does exactly the same thing that OS exit does. So that's sort of also just the right point to put the exit, because it's basically like saying, well, if I return from main, it'll just call os.exit 0 effectively. So now is a good point to run os.exit 1. That being said, it depends on the program, right? Like I could certainly imagine a program where you get to a point and you're like, there is no way I can proceed. Even if other things are still running, there's absolutely no way I can proceed. Maybe it just makes sense to drop everything on the floor.
Yeah. And I guess we have panics in Go for situations sometimes like that.
That's true.
Yeah, and that is interesting. Panics themselves are quite an interesting case then here, because they can occur anywhere in the program. And if on caught, they have the effect of ending the program. Mm-hmm. But defers do run with panics, don't they? We know that because that's how you recover from panics, is you run code in a defer function.
Precisely. So panics are going to run defers, and that's actually not the only thing that's going to run defers. If you do runtime.go exit, like you exit a goroutine calls runtime.go exit, it will also have its defers executed. And this is totally safe to do, because it's basically just the goroutine itself is synchronously, we know we're stopping execution of the goroutine at this point, and we're sort of walking back and doing and running all of the defers.
So yeah, if you're doing like runtime.go exit for a Go routine, I assume that you don't have the same cleanup guarantees that you would have with a os.exit call. Like how you said all the files and all the other stuff from the OS gets handled. I'm assuming that the Go routines files aren't kept track of separately.
No. So that's handled at a much lower level, right? So yeah, if your Go routine exits, that says if one Go routine exits, unless it's the last Go routine, of course, then that says nothing about the rest of the resources that the program might be holding on to.
Yeah, that's interesting when you think about things like HTTP response bodies. It's very important, you get a read closer when you get one of these. You get it if you make a request using a HTTP client. You get back a response, and that response may or may not have a body. And we're responsible for closing those bodies to clean up memory and things. Presumably that gets sorted out for us if the program ends, things like that, because they sort of rely on the underlying operating system for managing resources, right?
Right. So again, in the Unix philosophy of everything is a file, so is an internet connection. So is a TCP/IP connection, which sort of underlies all of HTTP, right? It's the backbone to this. It's on most operating systems built right into the operating system, and it's usually exposed through an interface that looks like a socket, and the interface for this in Go looks like a net.con, and that sort of represents the underlying connection. And so basically, if you os.exit, it's going to close that socket like it was any other file. So if you have a client on the other side listening on that connection, then it's going to be the same thing as if the connection was abruptly ended, right? So it's the same sort of failure mode.
Mm-hmm. Yeah.
The cool thing about some of these is you can actually test them. If you like go write a little program that just has a web server and just sits there and sleeps for 10 seconds and, curl into it or whatever just to make a connection and then close the server and see what happens. You can kind of see what's going on.
You mean as a client of a server just dying?
Yeah, like you can, like if you just use curl as the client to connect to your server that you just wrote, like running on localhost or whatever, and your server's just like doing like a sleep for 10 seconds before it responds, and you control C it or kill it before it's actually done. You can kind of see, well, did this close the body or respond or anything?
Quite a cool API, that. Just sort of restful mindfulness. Not restful, but mindfulness, sort of just sleeping. Little API to just sleep. I think that's a great idea, especially in today's world of just, everything's fast, going fast outside like in a film.
It's perfect. People call it to see if a web request is timed out.
Yeah, there you go. It's nice. Michael, how did you get into computers in the first place, mate?
That was like a long time ago. I actually started with what is now dead, Flash.
No, really?
That was sort of my foray into it, like a really long time ago. And then it just kind of spiraled from there. I thought I wanted to be an animator. Then it turned out I was terrible at drawing things. And then I kind of dug into the programming aspect and
action
got
script,
more
wasn't
into
it?
Yeah. And then I dug more into it in high school and college, and now I'm here. Well, several years later, and now I'm here.
Yeah. No, that's cool. Yeah, I used to do Flash as well. ActionScript got quite good as a language, didn't it? It got really quite, I couldn't believe all the things you could do with it at the end. But I agree. And I liked the fact, too, it was very visual, because for the web, you couldn't do that much with CSS, and you were very limited with stuff. So Flash was the way to get something a bit more interesting in the web back then. Nothing wrong with Flash. Yeah.
Yeah, I have very fond memories of using the the Flash, the actual Flash software itself, not like Flash Player, but like just like being able to drag and drop things, and like you click a little object and you put code directly on it, and like it just feels like, wow, I can put code directly on this button to like have it react to things. And
yeah, it sort of makes sense, doesn't it?
Yeah.
I liked the fact in Flash and in ActionScript, you had objects that were like base classes. So you could have other objects that were versions of that in some way transformed. So that was a very strange mindset to get into. But I suppose if you're used to OO programming, it probably fits quite nicely. I remember that being quite cool, where you could make changes to the base object and it would sort of cascade down the entire tree of them as well. Yeah, I don't know if that'll make it into the Go podcast, mate, about Go, but we'll see.
One of the questions that was asked, I believe, on Twitter was, why are deferred functions not run when os.exit is called?
I think there's actually a pretty good explanation here. So if you call go exit, right, then you have a Go routine that's saying I'm done, right? I'm gonna quit, and so it is totally safe for it to run its own defers, right? But now consider, like, you have a Go routine that decides, oh, I'm going to exit, and now let's consider this world where if you call os.exit, it runs all the defers in your application, right? So what ends up happening is the Go routine calls os.exit, and it stops everything else, and it asks all these Go routines wherever they are to start running their defers. The tricky part is it's not always going to be safe to run those defers. You don't know where those Go routines actually stopped. With the go exit, at least you as the programmer know, okay, I'm calling this at a point where I know the defers are going to run fine. So let's say you have a defer that relies on some variable that it captures. Like you have defer func open parentheses close parentheses, and in there you do something with a variable declared outside that's a pointer, and it's nil at first. But by the end of the function, it is actually non-nil, and it's relying on that to not actually panic inside of the defer. Well, what happens if some other Go routine calls go exit like right in the middle of that function's execution? Now your exit is going to cause this other Go routine somewhere else to panic, and that isn't what you intended at all, right? And it also brings this sort of global thinking into your code, where now you have to consider like, oh no, but maybe this can actually be nil because something else can call go os.exit. There is a valid question of whether maybe os.exit should, execute the defers of the calling Go routine, the Go routine that actually called os.exit. But it just seems a little, I guess, inconsistent to do that. It seems a little weird to just have that one go. But I don't actually have a good answer there. That for me could go either way.
I would imagine that one would be weird in the sense that if your defer somehow has like an infinite loop or something in it, which I know sounds weird, but if there was something weird like that, you'd probably want some other way to like finally terminate the program, I guess, programmatically. And, so like you'd need some other API that basically does what OS/exit does, but like not being OS/exit, and then it would just be weird. Yeah. And I think one thing worth like clarifying, which I don't know if we've actually touched on, is when you call os.exit, it terminates all Go routines, correct?
Yes.
I don't know if we've actually touched that, but that was like a big part of what you were saying there was like, if another Go routine gets shut down randomly, it's not the one in control of that.
Yeah. When I think about exit, I think of Go program as just like this one big black box, and it's almost like you're just throwing that whole box into the garbage, right? That's what I think of when I think of exit, right? And that includes all the Go routines inside, all of the resources that were contained within that box.
Mm-hmm. So it's interesting then. Do you think that's a sensible strategy? If you've got a program that maybe like John, you never expect them to end because they're that good and people rely on them that much, they can never end. Or if you've got a situation where you've got lots of Go routines maybe that are going to be running, but when you want something to stop, you're just happy that they all just get aborted and it doesn't matter. Is that an okay strategy? If a junior developer did that, would they receive scorn from senior developers?
I don't think so. I think generally speaking, there aren't that many cases where like a truly graceful shutdown is necessary, and especially because in those cases things get really messy, right? There are some resources that like you really do want to clean up, right? If you have a child process and you say that you want to wait for that child process to end before you exit, right? Or let's say you're running as root and you create a new network interface because you're Docker or something like that. When you exit, you might want to actually clean that up, and cleaning that up, especially in a large application, no matter what could possibly happen, is actually fairly complicated to do. So what my perspective on this tends to be, one way to look at it is have a graceful shutdown, try to clean up everything before you exit. Another way to look at it is just have your program be resilient to these to stuff being left on the ground. So when it comes back up and it sees that there's something with the same name already there, then it just deals with it, right? Or in some sane way. It's always going to be hard, right? This is always going to be a hard problem. Cleaning up or tear down or shut down, termination, whatever you want to call it, is always a hard problem.
Mm-hmm. Yeah, but I think that's good advice, though, Michael. Even if your program you're writing doesn't really need to do much graceful shutdown, it's quite nice practice to build that into a little command line tool, for example, where you interrupt the command C, even if there's just printing a statement to say that we're cleaning up or finishing or whatever. Mm-hmm. I think it is good practice building it in. Dave Cheney talks a lot about when you start a Go routine, know how it's going to end. If you think about long-running systems that have this long life, then it matters. It matters when things are going to get get torn down, especially if you're not relying on them to just be restarted all the time. So I think it is quite nice. It's nice to have that as a mindset, and also can help your design too. Like it might lead you to a slightly more elegant design if it's difficult to see how you're going to stop certain things from running. Maybe there's a simpler way to put it together, but I don't know.
Yeah, I absolutely agree.
Yeah, subprocesses are interesting. I learned by default when you run a subprocess, it doesn't get terminated when your program gets terminated. At least on a Mac, it didn't. And I had to set the program group. I think I had to set some group ID. I think there was some workaround. It was a strange thing, though. Do you know anything about what's going on there, Michael?
Yeah. So the way this works is that if a process has children and it exits, those on basically every operating system I know Windows has this exact same behavior, and so does Linux. That if a parent process exits, then the child is orphaned. Instead of just being exited immediately, which there, like you said, there are workarounds with this. You can treat the whole process. You can make a process group and send a signal to everything in there. Yeah. But if you don't do that, then the child is orphaned, and it has to have some kind of new parent to fit into this sort of hierarchy of processes. And on Linux, that means getting inherited by the root process, which is just this process that sits there and waits for its children to finish up. So if you do exit and you still have a child process running, it will continue to run until it closes.
Yeah, so that is interesting. That is worth watching out for, because I don't think that's what you'd expect to happen. I feel like if you think of starting up subprocesses, you'd expect them to terminate when the signal is received into the program that started them. But yeah, there are workarounds. One of them is, of course, to use command context and use context again, and that way, when you cancel the context, it has this cascading effect. I think of killing basically the sub processes. That's another way to do it, which is quite cool.
When you do it that way, if you just OS exit, does it end up propagating through all of those as well then?
No, I think OS exit just kills everything gone, doesn't it? So
yeah, so if you have Go code that's supposed to run to clean up your sub processes and you call Go exit, there's no guarantee that it's going to run.
Yeah, you'd have to exit through some managed mechanism, usually returning an error or something. Can be different ways to do it. It's just part of the design, I guess. Yeah.
And just to make sure I'm on the same page, when you're talking about sub processes, you mean if you're using I think it's command is the function in
yes.
Go?
Exec command.
Yeah, exec command, and then you grab the output or whatever from it if you need it.
Well, there's an exec command context as well that takes the context and kills the command if the context gets cancelled. So that's very cool.
Referring to, but it is interesting that doesn't exit, because I don't know what I would have really expected without reading the docs or hearing you say that, because I've definitely used it before, but I've never thought too much about it because most of the time I'm running really quick things. But I could definitely see if you were starting up a server, doing something external, that might lead to some weird behavior.
Yeah, well, it just keeps running the processes and you have to go and figure out why.
Also, I should say it'd be a weird bug where the next time you run and it's like, this port's taken. You're like, what? Why is it taken? Actually,
that is exactly almost, I think, how it manifests for me. It's always that case. Yeah.
Yeah, it's OS exit is actually, if you putting it into context, it's really low level when you think about it. It's not really. It really does just drop everything on the floor. If you want to sort of clean up a child, and actually I've run into this too, where I'm trying to clean up a child process, and now I have all of these complicated defer statements and using the signal package to capture control C so that I can try to gracefully clean up the sub processes and stuff. Because again, it's a server sitting on a port.
So you said that OS exit's pretty low level. If I recall correctly, in C++, don't you return the status code from main?
That's correct. But
I guess what I was going to ask is,
Oh yeah, sorry.
Like, what are your thoughts, I guess, around that as to why, like, Go obviously doesn't do that. So
It
if you were
could
doing
though,
that, I
couldn't
assume
it?
defers. What?
It could do that. You could
could, I
have
assume.
func main could return an int. I don't think there's anything wrong with that.
No, it doesn't. Like, I'm kind of curious. Like, my guess as to why it doesn't do that would just be that most people want to return 0 anyway, and it might be confusing to somebody. I know if you're first learning C++, you're like, why am I returning a number here? This, like, who's using it?
Yeah.
But I didn't know, like, when you want to actually have an error status code, the only way to really do it that I'm aware of, at least, is OS exit. And if you're calling that, then things might not behave the way you expected.
Yeah.
Well, yeah, I was going to say, so on that, specifically, like I've done it before where I have special error, like sentinel error types, which is another term coined, I think, by Dave Cheney. These, where you have a variable that is just an error type, or some other way of being able to figure out what the type of error is. And then at the very top in main, I always just call into a run function. And then I, on the response of that, check the error that returned from this run function and check it against any specific values for the specific numbers. Otherwise, I'll just return with some generic one. And that way you keep all of it in func main. All the OS exits are in one place. And you can kind of logically see the entire flow when it starts to get unwound.
We've talked about that pattern a couple times, and I think until you run into some of the issue, like the bugs, it's hard to understand how many different small bugs it can kind of prevent, like this, where like if you're doing it that way, all your defers in your run function will run, and everything else will run as you expect it to.
Yeah.
But if you don't realize that, I could quickly see just putting everything in main and calling os.exit and then being confused as to why something didn't defer, like some defer didn't run.
Yeah, I think that's a good point. One of the nice things about not having an int return from func main is that it is kind of simpler. So it is that expected thing, and it looks like other Go code. Of course, returning an int would as well. But yeah, it's those run. I love those little run function abstraction things. I do it as well where I pass arguments in. So even if I'm going to parse flags or something, I do that inside the run function, pass in the OS args, because I can test that entire program in test code without any shenanigans, just by calling that run function with different arguments and check the response, So yeah, that one turns out to be a great. And often I'll take a context into that run as well. And that allows me to even test cancellation and timeout and things. I can make sure that if I set a timer in a test for 1 second and I kick off the program, I can check the time difference after to make sure it wasn't too much longer. And then I know that my program is respecting cancellation in context, for example.
So Matt, you talked about graceful shutdown quite a bit. Can you give some examples of like more concrete examples, I guess, of when somebody should be thinking about it?
Yeah, well, times where I've done it, originally in a sort of HTTP context, we wanted to finish any current requests before exiting. That's now built into the HTTP package. I think you can use listen and serve in a specific way to get that. I'll check that and put it in the show notes. I need to just write that down because I sometimes have promised show notes and not delivered them, and then I've received quite a stern telling off. Sorry about that. And another time is if I'm processing files, and I'm going to be doing some kind of IO copy or some operation like that, where I would rather not interrupt it and leave some weird half file. That I don't know what's going to happen with it. It could become self-aware. Could probably not, but you don't want to take chances. That's how things happen. So yeah, it's things like that. I don't know if it's that big a deal, whether I would let it just be a corrupt file, because maybe I'm deleting all the files when I run this program anyway. But I like the practice of making programs gracefully shut down. And then it's a tool I have in my tool belt that I can just use whenever I need to.
I definitely agree with the practice part is good to keep there so that you're doing things the right way when it actually matters. Because I know, like I said earlier, I'm guilty of not always gracefully shutting down. And one of them is where you said about cleaning up files. If I were to just Control-C a program that was doing something with files, I would just assume all the files are probably not valid, delete them all, and just restart if it was generating files.
Yeah,
And
that's another strategy, isn't it?
Yeah, I mean, for quick things, it's like, all right, is deleting the files and rerunning the program going to take more time than writing graceful shutdown code? So you kind of have to like weigh which one makes more sense. But if it's like a one-time program, then sure, whatever. But if it's something you're going to be using a ton in a company, then maybe that doesn't make sense.
Yeah, I think it also depends on the situation as well. Because another time I've used this is when we were going to run code in like Docker, and running in some kind of cloud environment. The interrupts are essentially the platform telling you that this instance is going to be going away, and you may well be in the middle of handling some request, if you know where that could happen. So yeah, that's another time where we've had to just take the signal and don't just deal with it. Don't just OS exit, but hold on to that signal, usually in a buffer channel with space for one buffer at least, so that you don't block there. And then just wait for it, finish the work, and then exit. Don't take on any new work. That's the other thing. You sort of flip some switch to say, no, we're in shutdown mode now, so we won't receive any more traffic. A lot of these problems are probably solved, but I think depending on, like, if you look at the 12-factor or 12-factor application kind of design, using these fundamentals and being consistent like this, it just has benefits, because other systems that are going to be running your code or interacting in some way will also expect this kind of behavior. So there's something to be said as well for being a kind of good citizen in the operating system, I think, as well.
I think the 12-factor stuff is something that definitely plays a big role, because, I mean, for anybody unfamiliar, it basically means one of the big things of it is that your server can be shut down pretty much at any time, and you'll lose anything that was on the hard drive, or anything like that. So like you can't really count on all of those local file systems to be there. And like usually there's workarounds around this where you can directly upload files to wherever you want to get them. But I've definitely seen services where you upload a file and then the server will take and process the file or something and upload it somewhere else, like S3 or something like that, or Google's, image or blob store. And if you're doing something like that, I could see graceful shutdowning being something that's vital, so that that somebody didn't upload an image and then you don't actually push it where it needs to go, because that would be frustrating for the user to be like, well, the image was uploaded, why isn't it still there?
Yeah.
All right, I think we are ready for unpopular opinion.
Okay. It's that special time again, so gather round, children, with your pints of beer. I've got nieces and nephews, but I don't know what I'm doing. It's time for unpopular opinions. Okay, who wants to kick us off? Michael, do you perhaps have an unpopular opinion?
I'm sure I have lots. And I want to preface this one with saying that, my mind is absolutely open to alternatives in the future. This is not a hard and set thing. But my thinking right now is that, and this is maybe going to go a little deep, but I don't think the Go garbage collector needs to become copying or a generational collector. So if you're not familiar with those terms, don't worry about it. But I think going forward, we can actually, there's enough room to grow here that we can make a really, really, it's already first class and quite good. There's been a lot of excellent work put into it. But I think there's so much room to grow here that the common sort of, there are lots of reasons why the common thinking of like, well, of course generational garbage collection is going to make your programs run faster. I think there's a lot of reasons why that same sort of thing doesn't hold in Go. And I think that there are actually better paths forward going forward. So that's my unpopular opinion. And of course, maybe I'll change my mind in like a year or two, but that's where I am right now. That's where I've been for like a year.
No, that's a great one. Well, we will be testing these on Twitter. We do the poll and find out if they are popular or unpopular. That's going to be an interesting one. John, what do you think? You probably, I suppose you don't use garbage collection because none of your data is garbage or something?
No, I use the garbage collector all the time, Matt.
Ah, okay. What do you think about that opinion?
I am probably in agreement. I don't get worked up about the garbage collector like other people do, though. Like, I don't have any need for it to change, or, you know, like yes, it's been improved and that's great, but most of the time garbage collection is not a limitation for me. So it's not something I think about, is the best way to put it.
Mm-hmm. Is it that, Michael, that it could be in some situations one approach is better than others, depending on the situation?
Absolutely, yeah. The design space for garbage collection is quite large, and you have for general purpose application, it's almost sort of feels like a lot of different languages and runtimes have sort of settled in a particular place. But there are a lot of niche sort of collectors. But I think maybe it's worth exploring that design space in the for general purpose programs too. And I think Go has some special properties that make it particularly worth looking into.
Yeah. I know somebody who turned off the garbage collection because they had this program that just ran for a short amount of time and would never need that much RAM. And it just ran like kind of lightning fast, so they didn't have the garbage collection happening at all. Which kind of,
how do you turn off the garbage collection?
It's a flag, isn't it, Michael?
Yeah. So Go's garbage collector famously only has one knob, and it's called GoGC. You set it via an environment variable, or you can use the debug.set gc% API runtime /debug.set gc%. And what it does is it lets you make a trade-off between CPU and memory, but you can also just say off. So you either pass it a negative number in the runtime API, or in the environment variable, you just write off. GoGC equals off, and it won't collect anything. It will just keep allocating memory, even if it's garbage. It won't try to collect it.
So this is the perfect way to make sure my programs eventually shut down.
Yeah. It's funny when you look at memory profiles. Sometimes because you can look at a memory profile and see like the total amount of memory that your application has allocated, and for like a long running server, you'll see like several terabytes or like petabytes of information depending on how long it was running going through there, and it's like, wow, if I didn't have a garbage collector, this would have died a long time ago.
That's funny though, but those numbers are never, you never have any frame of reference for those numbers, really. It's like when they see it on the news, they'll say, in the UK, people have drunk 50 billion cups of tea. And you think, well, is that a lot? I mean, it sounds like a lot, but maybe it's not.
It's like, maybe it's just know how many people there are there. I got to look that up first.
Exactly. You have to. So it doesn't help, does it, knowing how much RAM you've needed in the lifetime? Although I'd like to see it.
It's useful for finding like memory leaks and stuff for sure.
Yeah,
and other
like
things.
Infographics.
What about that idea though of just don't worry about it, turn off garbage collection, rely on that sort of hacky, sounds like a hacky thing, but somebody made the case for doing that in a cloud environment where you just have these little short running function like things that just spin up, do their work, and then disappear, kind of like a Meeseeks or some other, I don't know, I can't use that reference, I don't think. But what about that as a strategy? Is that just mad?
I don't think it's totally mad. I don't know if you know about, or if the wider Go community know, or probably because, but the Plan 9 C compiler, like I somewhat famously didn't, like it just allocated memory and it never freed it. It was written in C and it just called malloc, but it never called free because the assumption was by the time you're done compiling, whatever, just the OS will clean it up. It's fine. So for short programs, there is some wisdom here, right? And I've known other systems that have done something similar, right? Because there are performance gains to be had. If you know you're not going to run for a very long time, then of course that it works. Of course, I will say that like in most cases, probably doesn't make sense, right? It could certainly be like a premature optimization, especially if you have like a command line tool that's growing to do more things. One day it's just going to crash, right. And you won't know why. Yeah. it can be valid in some circumstances.
Very cool. Well, it's that time where I'm cancelling contacts. I'm going around giving you signal interrupts. I'm not going to kill you, but I'm going to be calling OS exit on this episode. Thank you so much for joining us, and you'll have to come back and talk about some other things in the future too, if that's all right. We'll test your unpopular opinion on Twitter. If it's not unpopular, you do have to come back. That is legally binding. John Calhoun, always a pleasure.
Thanks, Matt.
Want to say something? Want to say something nice to me?
Right now, I'm the only person who actually has os.exit for Zoom. You guys can't end the meeting for everybody, just for yourself.
Oh, you've got it. Yeah, you've got the power of the exit. Yeah, all we can do is call runtime, that runtime one for Go routines. Pathetic.
Zoom doesn't quite work the same way. It doesn't give everybody that permission.
Fair enough. Okay, well, thanks so much, everyone, for joining us. See you next time. Okay, that's it. Then the music plays, and I don't know what happens. I suppose people just get on with their lives, do they, after when the podcast is finished?
That does make me kind of wonder. Is there a way to limit a Go routine from not being able to call os.exit?
No. It kind of parallels the C standard library function exit. We don't really and it's totally fine to get into it because this is about a different language, but the C standard library buffers a bunch of things. So when you call exit, it will also do a bunch of work to flush buffers to files and stuff. Go doesn't do that because os.files are buffered. But no, there's no way to limit it. It's like the C standard library function where it's just anything can do this.
So that means if you're using a library that is written poorly and just OS exits randomly, it could definitely cause a weird bug.
Absolutely. And I will also point out that this API is kind of like a Unix API, and it's from the era of all computers only had one CPU, and so and one thread, before when process and thread meant the same thing. And so all of these a lot of APIs aren't really built to work with this very well. Fork is another example of one of these APIs that it's just if once you have multiple threads, things really start to break down. Yeah,
I was always amazed in the Terminator when it's like, this is my CPU, and he just had one little thing, and I always wondered how many cores has he got running on that, and is it I know his GPU wasn't great because it was just read with text, but there's a lot of processing still, and must use a lot of machine learning. So it probably did have integrated GPU as well. I don't know. I didn't go into it in the film. Maybe it's in the DVD extras.
Do you watch this movie with a notepad out, just jotting down notes as you go?
No, it's old enough that it's kind of a classic now. So I've seen it. I've watched it enough Christmases that it's basically baked in. Yes, I sit with a notepad.
I'm thinking the Terminator on Christmas is not the movie I would have expected.
Yeah,
I have a hard enough time convincing my wife that Die Hard is a Christmas movie. Still doesn't believe me. I had to legit get a special edition of it that has Christmas themed cover on the box, and I'm look, This is clearly a Christmas movie.
Okay, but then that works with anything. Anything's a Christmas thing.
But they officially released it, and it's based during a Christmas party.
They're just stoking this big internet fight that you're also just stoking.
All right, quit fighting me.
Yeah, it's like the mildest form of internet trolling. I mean, Die Hard is a Christmas film.
It's more for me. She's like, I want to watch a Christmas movie. I'm like, perfect, I've got one. And then she's like, no, and I'm like, I don't want to watch a Hallmark movie right now. You
say, well, Nutty Professor 2: The Clumps isn't a Christmas film. We've had that on all day. Do you know what I mean?
I don't even know what happens in that movie. So
loads of things happen. There's lots of science in it.
I can imagine. All right, I'm going to stop recording. If that's
me
fine
too.
With everybody.
It's fine by me. And I'm going to export the audio file.
We are still live, by the way.
Okay.
We can end that whenever, but.
Okay.
Thank you for joining us, Michael.
Yeah, of course.
Yeah,
It was
great
a
job.
pleasure. This was fun.
Yeah, you'll have to come back another time.
Was it worth being nervous?
Yeah, I think so.
I mean, was there anything that how do I rephrase that?
What did I say? He's trying to see if he can
No,
get.
I'm trying to say
in trouble for my performance
do you think
review.
you'd be nervous next time?
Definitely less so. I've just never really been on like a live podcast, especially not like a popular one. So
if there was one person on it that you said helped you the most, who would you say? If you not hero, but well, another way to put it, if there was someone on it that's been a bit of a villain, like perhaps got a kind of colourful. Like a strangely colourful background to try and fool you, like the child catcher from Chitty Chitty Bang Bang.
Well, I'm afraid if I actually pick someone for either of these questions, then I won't be invited back on. So I'm going to refrain from answering.
Well, it actually would just be a Twitter poll to find out, and then that's the person.
Popular or not.
Either me or John is not allowed back on based on popularity. That'd be good.
We don't even do this on an episode with 3 panelists. It's just 2. So it's like one of you is out.
Yeah. Right, sorry, I've just got to find a file. Finding files is still hard, isn't it?
Trying to make sure that I don't accidentally throw this recording away.
Yeah, please don't do that. I mean, I have a backup, but please don't do that.
It's not easy to see which folder this is.
Trying my best.
Oh. Okay.
Okay. I think I got it.
I remember when I had a fresh install of the OS and I didn't have any of my own folders or anything, and it was all clean and neat.
I was actually just the other day, I was like, there was something when my computer was all messed up and I had to go fix it. But in the process of fixing it, I know, like Emacs wasn't working and I have no idea what changed. I think it was when I was installing something with Ruby that screwed it up. But anyway, it wasn't working. And like, I was seriously considering just wiping my computer and starting fresh. Is that going to be faster than trying to figure out what is going wrong right now?
Wow. That's quite an extreme form of turn it off and on again, isn't it?
Well, like I've gotten in the habit of like, at least every time I get a computer, obviously, but even then maybe once a year, maybe once every 2 years, I'll like freshly wipe my computer just to get rid of stuff that I don't need and just sort of clean things up.
It's suspicious. Carry on.
Suspicious. Okay.
Yeah.
No, to the point that I actually have like a guide of like, I've written a markdown file of like, here are the things I need to install and what order to get most things back the way I like them.
Right.
And so sometimes it's not too bad to do it. And other times it's like, that's going to be a lot of work.
Do you have a bag as well by your door that in case you need to get out quick?
I've got a bunch of magnets, just because I like to play with magnets. No real reason.
Yeah. Sorry, I made a joke of what you said, but I was actually interested in it. I hate it when I do that. I miss out.
Matt.
And I have to miss out.
I feel like I do the opposite. Instead of having a bag turn out the door, I just kind of have this
a bag that runs if you have to quickly run inside.
no, if I have to quickly run outside.
Oh, right.
I mean, like if I've kind of got this attitude with like software environments that if I'm if I have to change to a new one, I like sort of keep an emotional distance between like my environment. So on a new machine, I'm just gonna start fresh. I'm not gonna try to bring it back to how I like it. I'm gonna find something new to like.
Yeah.
And I just throw it all out and I start over.
I do that too. I'm with you. Yeah, I do that with a phone. It always says, "Do you want to restore from from your old backup?" And I never do. I never want that. I always like it. I don't know. I like it to be fresh and kind of new. And also, it's quite nice to see what the defaults are sometimes because they change. So I'm with you, mate. Yeah, I agree.
Yeah,
I've done that with some things, but
yeah. I'm not saying I don't customize. It's just I customize just enough that I feel like if I really wanted it, I could do it from memory.
I guess part of it for me is like there are some things that I know, like I've basically tried to start fresh and I've ended up at the same thing 4 times in a row. And I'm like, okay, that's probably the one I'm going to stick with. Like another example you mentioned on the phone, Matt, like I've started fresh without installing any of the apps. And like when you go and press somewhere on your screen expecting an app to open and it doesn't, you're like, oh, that's where I had that icon. I should probably put it there.
That's right. Yeah. Then you put it back, and it's sort of on demand, isn't it? Then it's kind of like just in time. It's okay. I mean, we used to have to go outside, and then you couldn't always do the same things. But now that's not. I don't even have to charge my phone anymore. I just will occasionally be close enough to power where it will. Yeah, I mean, I plug it in, but I mean, it's like a passive thing now. It's not an active, because I don't have to go anywhere. Batteries are a waste of money, weren't they? Pointless. That's the biggest shame of COVID. Wasted battery technology.
Yeah, all that innovation, years and years of people's work, and it's just like, well, now everyone's just near a charging port. So
they could have been exactly. They could have been working on receded hairlines or something. Do you know what I mean? Something important.
I'm curious how many people could have gotten rid of cell phone plans had they like realized how long this was going to happen.
Yeah,
because when you're not going anywhere, it's like Wi-Fi usually suffices.
Yeah, that's a good point. There'd be a lot. I actually have a plan that's like I'm 16 years old, and it's like a prepay, like a credit top up thing. That sometimes can run out of credit, which is, as an adult man, extremely embarrassing when that happens. Oh, sorry, I can't just do that basic thing because I've run out of credit. Imagine having to say that in a grown-up's body. That's what. But that happens, and. So I was able to just stop updating it. I haven't needed it, But yeah, anyone on an actual phone plan?
I was gonna say if I had like I just have been on an unlimited data plan for a while because if I was traveling at all, it was nice to have to tether and do different stuff like that. But the tethering's limited, but still. But yeah, like if I was on like a data plan now, I imagine my bills would be pretty cheap at this point. I actually have a friend who, whenever he left the one company he was at, all he had was like the work phone. So that was the only number he'd used the whole time he was there. So when he left, he had like a personal phone, but he didn't have a cell phone plan for it because he just never used it. So all he had was Wi-Fi for like the first week until he actually got a cell phone plan. Yeah. And it was pretty funny when he'd be coming over to your house to hang out, and you'd like randomly get updates when he passed someplace he knew had Wi-Fi that he could connect to. But otherwise you just like wouldn't get an update.
Yeah.
And he did this for like a week until we're like, dude, you need to get a cell phone plan, like something.
Yeah. We had a lot of family visiting from abroad one time, and they were tethering on my phone. So when I turned up, or if they arrived where I was, suddenly all their phones would come alive. So it was like when I walk in, it's like bing, 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 just like noises everywhere. It was like Vegas. Sounded like Vegas when I walked in.
You think it'd be frustrating because you show up and then nobody wants to talk to you. They're all like checking their phones all of a sudden.
Yeah, they've all got data. Now I'm the bringer of Wi-Fi. Just sort of walk in and, I mean, really, yeah, it doesn't happen very often where people like me. So really like to cash in on those times.
Maybe that's why you have so many chargers around your house.
Yeah, charger, anyone? Do you need a charger? You boy!
I was thinking all the people there were just like, Matt's phone can't go dead, so we got to make sure there's a charger everywhere.
Yeah. I don't know. Well, I've got basically an ensuite charger because my flat's so small.
I'm going to end the stream.
Yep. Bye, everybody.
Bye, everyone.
EOF, I guess.
All right. So that is done.
I've uploaded. Michael, have you uploaded your